The Amazfit T-Rex2 is one of the toughest smartwatches on the market. It's passed 15 military-grade tests, including resistance to low and high pressure, extreme heat, extreme cold, rain, salt, sand, dust, vibrations, shocks, acid and fungus. Basically, anything you can think to throw at the Amazfit T-Rex2, it shrugged it off with no issue. For all you explorers, adventurers, fans of the great outdoors, the Amazfit T-Rex2 is ready to evolve your instinct anywhere in the world. But Amazfit aren't a company who rest on their laurels, not by any means. They wanted to push things further than any smartwatch has gone before, into space. And that's where we came in. This smartwatch is built with military-grade toughness, and our job was to push it to its absolute limits by taking it into space. We wanted to get it as high as possible above the Earth into the most extreme environmental conditions we could reach. At 100,000 feet, which is about 32.5 kilometers, 3 times the cruising altitude of a jet, the two main challenges here are pressure and temperature. The air pressure is less than about 0.2% of what we would experience at sea level, and the ambient temperature can get as low as minus 60 degrees Celsius. But due to the lack of atmosphere, objects which generate heat also can't dissipate it. So here we have to worry about both the heat and the cold. Both of these have a dramatic impact on battery performance. It's an engineer's nightmare, and the vacuum of space, really, it's just part of the challenge. The watch has to survive the journey there and back again, traveling at speeds of up to 200 miles per hour and landing in uncertain conditions.
The biggest challenge we could foresee was temperature. Under ideal conditions, the Amazfit T-Rex2 boasts an incredible battery life of 24 days, but space is far from the ideal environment for a watch, even one as rugged as this. To protect its battery and components, the Amazfit T-Rex2's military-grade certification includes resistance to temperatures as cold as minus 40 degrees. The watch even has an intelligent ultra-low temperature mode, which when activated, allows the device to enter a power-saving mode whenever the watch's surface registers a temperature below minus 10 degrees. In this mode, Amazfit reckon the device can remain in operation for up to 10 hours with the GPS enabled. So it seems the T-Rex2 is more than able to handle the cold, but we wanted to find out if it stood up to the freezing conditions of space too.
Securing clearances and planning the flight path was the final step, and at last we were ready to head out to the launch site.
On the launch day, we used a hydrogen gas-filled stratospheric balloon to carry the spacecraft and the watch on its journey. Once the combined balloon and ballast were floating, we knew that the balloon had the right amount of lift force and could then be sealed off and attached to the craft. The whole team were equipped with Amazfit T-Rex2 smartwatches, tracking their excitement, or maybe in this case anxiety, throughout the launch day. With precise heart rate, blood oxygen saturation and stress level monitoring, we've never had a better record of any spike in panic within the team. Once we had everything sealed off and had final clearance from air traffic control, it was time to prep the Amazfit T-Rex2 for flight. We wanted to test the dual-band GPS and 5 satellite system support, so we activated the outdoor cycling mode to log positional data on the watch. With the watch in the air, we sent our recovery team out on the road to the projected landing site in preparation for the landing. The spacecraft climbed through the atmosphere for 1 hour and 43 minutes. The T-Rex2 intelligently dims the screen to save power, but even at the peak of the flight, where the sun is 60% brighter than on the Earth's surface, it was still visible. Incredible. As it ascended, the pressure dropped. Now that changing pressure caused the balloon to expand, and by the time we reached peak altitude at 34,553 meters, the balloon was the height of Buckingham Palace. Meanwhile, our team were on the road tracking the Amazfit T-Rex2 and refining our simulations for the landing location. Weather and road traffic conditions were subject to constant change, so the always-on compass was really useful, especially when going off the main roads and down winding country lanes. We were really impressed with the performance of the Amazfit T-Rex2 and using the compass to keep us on track with a superb degree of accuracy. Our flight path predictions are very accurate, but there's always a few variables which we can't anticipate or control. We can calculate the expected landing site to within a few hundred meters, but almost all of that margin of unpredictability is in the last few moments, because the interaction of wind and local geography creates an inherently complex microclimate as we get closer to the Earth. So that means our recovery team were very much kept on their toes trying to stay under the craft as it landed. And we got a great insight into that thanks to the stress monitoring feature on our wrists. Working with Amazfit was a real pleasure. There's a lot of smartwatches on the market, but there's very few I'd be confident with to take on one of our launches into Death Valley or the glaciers of Iceland, or perhaps on one of our aquatic recovery trips to the Pacific. I mean, this is a watch that can go into space, come back working without a scratch on it. We're used to designing equipment that works in extreme conditions, and we've got a lot of respect for the team at Amazfit. For all you would-be astronauts, there's really no better watch to help you evolve your instinct.